Hello, we're here today demonstrating the No-Mor Friction Ionic Friction Reducer Metal Conditioner product. No-Mor Friction is being sold here by an independent dealer, so the fuel desk won't have any information about the product. But to order No-Mor Friction or for any questions, please call the toll-free number on top of the TV set. To demonstrate the effectiveness of the No-Mor Friction Ion, we're doing what they call a block and pin test, which consists of the big red drill that is able to bear down over 2 tons of pressure. We have an amp meter here that is measuring the drill's electric power consumption during the test. And we have a non-contact infrared thermometer, which I'm using right now to measure the temperature of this light bulb. We like to think of this test as something like the way the Indians used to start a fire by spinning a stick into a hole. We've used this 1/4-inch drill bit to drill holes halfway through this bar stock here. To run the friction in the holes, we have some 1/4-inch rods that we have dressed with the grinder wheel back here by putting straight grinder marks on them. Because all the grinder marks are going the same direction, any kind of friction that would be created by spinning these sticks in the holes is going to make circular wear on the sticks. Now in the test, we're going to run extreme pressure on these pins as they are lubricated with different lubricants in these holes. We're going to use the meter to measure the fuel economy. We're going to use the thermometer to measure the heat. And then we're going to... Hello, if you just got here, what we're doing is we're getting ready to demonstrate the No-Mor Friction product. And we're talking about making big trucks go down the road with less friction, less heat, less wear, and operating on less fuel. The test we have here consists of a block and pin test, which is these rods. Let's have a closer look at the ends of these rods if we can. And this bar stock, which I just in the holes with a different lubricant. For anybody who's just stopping by, what we're talking about is making trucks run down the road cooler with less friction and operating on the least amount of fuel. We're going to get started with some regular motor oil. So I'm going to put some regular motor oil into the hole. I'm going to put these pins over here. And what we're doing is we're spinning. This rod is going to spin in the hole. And we're going to test it for friction, heat, and wear. Are you there? I'm walking it slowly down into the hole. I'm gradually increasing my pressure. That's a frictional lockup. Now let's take a look at the amp meter, and let's do the same demonstration again on the amp meter. How about that? Is that any better? Okay, you can see where the amp meter is running now. I'm going to walk the pin down into the hole again. This is operating with regular motor oil. If you just came by, we are talking about running trucks on less fuel with less wear. You can see where it's at now. That's your frictional lock up there, how it pegs out. Did you see that? Now, we're going to try some other additives in the same hole that is already becoming worn with the oil. All the products that we show in this hole, we will give a shot with a new hole in a second. Most of the oil treatments or engine treatments out there work either by coating your parts with something or changing your oil's viscosity, making it thicker and thinner. Here we're testing a popular oil stabilizer.
The purpose of these oil stabilizers is that in the event that heat would ever thin out the viscosity of your oil, the oil stabilizers will help to keep your oil's viscosity thicker. What we're going to test here is whether or not oil stabilizer will get rid of any of the friction, the heat, or the wear, or if it will make the pin to operate better in the hole. So, can we see where the pin is going in the hole now? I'm going to use just a finger for pressure with a thick kind of product. And we have a frictional lockup, and can you see how much metal we developed? Quite a bit of metal is developing. Now let's do this test one more time, and let's take a look at the amp meter. For folks who are just stopping by, this meter is measuring the drill's power economy. Right now, how much electricity it's using. I'm going to walk it down into the hole with just one finger of pressure, and you can see it moving with the oil stabilizer product. How's that? Is that where you need to see it? Let's try that one more time. This is oil stabilizer. And I'm using just one finger worth of pressure. Watch the meter here. That's a frictional lockup. Now, sometimes to get rid of friction, they will use products that contain particles of solid substances, sometimes moly, sometimes graphite, sometimes Teflon or silicone. Here we're testing the very popular Teflon lubricant in the same hole, again, of course. Can we see the pin in the hole? I'm going to use one finger again with the Teflon lubricant. That's our frictional lockup with that. Now let's take a look at the amp meter when we do this. For folks who are stopping by, right now we are talking about getting rid of friction, heat, and wear in engines and equipment, and increasing the fuel economy of big trucks. Now, see where the amp meter is reading now? Let's watch it here now with the Slick 50. See how it's climbing? And then it slams over. Now we're going to show how the No-Mor Friction product works. Can you see the bottle here? This product is ionic friction reducer metal conditioner. That means it uses charged atoms, ions, to eliminate the friction, the heat, and the wear. It's a fully synthetic product that contains no oil, contains no solid particles, no graphite, Teflon, or moly, synthesized from soybeans, petroleum hydrocarbons, and farm animals. Not a lubricant fortifier, has no silicone in it. And if you can see the back of the bottle here, can you see that? It mixes into oil, it'll mix with water, mixes with refrigerants, hydraulic fluids, milling and machining fluids, transmission fluids, and more. And what it does to get rid of the friction is it generates free electrons into your equipment. When you treat your engine or treat your gearbox with No-Mor Friction, it does not just treat your parts, but it treats all the microscopic wear that's floating in your oil with free electrons. I'm going to put just a little bit here, just a couple drops in the hole. Can you see how much I'm putting? This hole is filled with ground up metal. Can you get a little close up of the hole so we can see what it looks like? As it runs in the equipment, it generates free electrons that positively polarize everything. If you take two molecules and give them the same polarity, and then try to rub them against each other to generate heat or wear, it will not create wear. There's no heat developed between two like-charged molecules. Now, let's see if you can see my finger up here on the handle. You see it? I'm going to walk this slowly down into the hole. The No-Mor Friction polarization is not immediate, so you're going to see my finger bouncing up and down with the friction. You see it bouncing? Right now it's giving off free electrons It has smoothed out the hole. Everything is positively polarized in the hole now, and we are not generating any more heat or wear in this situation. Let's take a look at the amp meter now. Can you see that? For folks who are just coming over, we're going to read with this amp meter how much friction there is, how much draw there is on this drill in this situation now that we have polarized it with the No-Mor Friction. Are you here? I'm going to increase my pressure. And as we do this, let's also take a look and see how much pressure we're putting on here. And do you see any change here happening in the amp meter? We're not generating any kind of friction, any kind of wear of any kind, of course. Are you able to see that happening? Do you see how much pressure I'm putting on the drill? Now, for everybody who has just come by, we are talking about using charged atoms to eliminate friction, heat, and wear. If you have any questions or if you'd like to order some product, call the number on the TV, on top of the TV that we have here. Because we did use the popular oil stabilizer product in a hole that was already worn out with motor oil, we're going to do the next stage of the test with the same popular oil stabilizer product, except that we are going to use one small drop of No-Mor Friction. Can you see the hole here? Watch how much No-Mor Friction we're using. One small drop of No-Mor Friction to defrictionize the hole. Now, this gives us a way to see how much wear we would have had if we would have been treated from the beginning. And then we're going to compare the wear in all these holes. Would you guys like to see the, I think we'll show that hole with the No-Mor Friction first so we don't have any heat building up on our bar, so we can see how cool it stays. For everybody who's just coming over here, I have an infrared thermometer here that we're going to use to measure these temperatures. Right now I'm measuring a light bulb. Can you see how that reading came out? And if anybody else would like to pull on this and feel how incredibly smooth this is, you can come over and pull on this and just feel this. Do you want to feel it? You won't believe it. It doesn't feel like there's any connection or contact happening. Would you like to feel this? Just come pull on the handle here and just feel it. Feel how smooth that is. We're not generating any kind of heat. Watch here, guys. Let me know whenever I have the thermometer at the angle to which you can read it. Is that it? I'm putting pressure on here. 78 degrees. 79 degrees. Can you read that? It's not getting any hotter. The main reason I was asking someone else to pull on it is because it's hard for me to hold the thermometer and pull on it at the same time. And plus it shows how hot it's getting if someone else pulls on it. You see the 83 degrees? We're not creating any kind of heat. We're not creating any wear. Let's take a look at the amp meter here one time. And for folks who just came by, we are talking about using charged atoms to polarize your gears, get rid of the friction, heat, and wear in your truck, make your truck operate on less fuel. Okay, are you seeing the meter now? Now, this is with no load. This is with a tremendous load. We're not making any change whatsoever. Now, let's take a look at how easy it is to change this. Can you see my hand in the picture? I'm going to put just a little friction with my hand and we can see the difference. We're not making any kind of friction, heat, or wear here. Now, the No-Mor Friction product is not oil. For folks who just came over, let's look at the back of the bottle just one more time. It says here, can you see it? Mixes into oil, mixes into water, mixes into refrigerants, hydraulic fluids, milling and machining fluids, things like that. So here, we're going to show how the No-Mor Friction can protect you from one of the worst things that can ever happen. Can we see the hole here? This is antifreeze. Antifreeze is good in your engine as long as it stays in your cooling system. But everyone knows if it ends up in your oil, that oil and antifreeze will not go together. Can we get a close-up here? The No-Mor Friction product is a recreation of a military technology that is made to keep equipment operating under crazy conditions. You could have guessed it wasn't developed to make owner-operators have more profit or to make trucks go down the road with less fuel. But watch here. This goes directly in with the antifreeze. There is no oil in here. Now let's blenderize it one time. This forms a soluble lubricant with the antifreeze. Now, because the No-Mor Friction product mixes into oil, and because it mixes into antifreeze, we can put the oil back in there, and it will mix the antifreeze and the oil together. Normally, this would look like cottage cheese and chocolate milk in here, all garbled up with a bunch of bubbles and all that. The No-Mor Friction won't bubble, it won't separate. Would you like to pull on this handle for a second so I can hold the thermometer? Now this gentleman here is going to put a lot of pressure. Put a lot of pressure on there. He's putting a lot of pressure on there. Let's check the temperatures here. Can you see the numbers on the thermometer? Are they coming through clear? This is an 84-degree situation. Now for folks who are watching this, in just 1 second here, we're going to do another pin without the product, and we're going to be able to get an idea of what kind of temperatures really develop in this test. You're not making any kind of friction. Does that feel smooth? You can't feel any metal-to-metal connection at all, can you? That's because the pin and the hole have both been polarized. Now, if you can make your gears go around without any kind of connection, you take the bonding force off your gears. Now you can climb hills a whole lot faster. Now you can go up the mountains without having the gears to get hotter and swell up. He's not creating any kind of heat here whatsoever. Now, let's take this pin out, and let's do one from the beginning without the product. We just put some popular oil stabilizer that has a tracker on the bottle in this hole here. This pin is the one that we just used with the No-Mor Friction. For the folks who are just coming over, if you can see these grinder marks on here, what we're doing, and we use the grinder back there to make straight marks, because any kind of wear is going to be circular that develops in this test. Now, you were putting a good bit of pressure on there a second ago, right? The difference in wear here was because the pin and the hole were polarized the same. The No-Mor Friction doesn't make things slippery. It doesn't put any kind of a film on your parts or try to put any shield on your parts. It uses a molecular principle of the universe that says opposites attract, like charges oppose each other, and it gives everything the same polarity. So now we're going to run this very popular oil stabilizer in the same test, except this time we don't have any polarization taking place. We have the bonding force and all the friction that would normally be there. Now, can you see my finger up here? I'm just going to use one finger to operate this test. You see my finger? I'm going to start to use my finger muscles to push down on this pin. And we're going to check for protection of our parts. That was a frictional seize-up without the No-Mor Friction ions. Now, can we get a close-up on this hole? We had a seize-up with the pressure of one finger. Now I'm going to try to operate it. I'm going to put some more of the oil stabilizer in the hole to see if that'll help it to go around any better. And we're going to then test for wear. Are you able to see the hole good? You got it now? Is it in there? Okay. We're going to run this in here and see what kind of wear it develops. I'm not going to seize it. I'm not putting any pressure at all. Still locking up. We're creating some wear. And now we're going to check it for temperature shortly here too. I'm really trying to get it to operate a little bit. I'm trying to pull it out if it starts to get locked up in there. We're creating quite a bit of wear. If I can keep this running long enough that I can get my thermometer out, we're going to be able to see how it does. And for folks who are just coming over watching this tape, we're demonstrating friction, heat, and wear. Okay, can you see this thermometer? Can you see the thermometer reading? I'm not putting any pressure. This is with no pressure. I'm not pushing down at all. I'm trying my hardest to keep it running without seizing. That was a lock up there. This is the same test that just moments ago. We'll put some more oil stabilizer back in there so we can get it to run around longer. This is the same test moments ago that wouldn't get past 85 degrees for temperature. Now we're at 162, 183, 84. Can you see the temperatures? 187, 208, and it's locking up. Now it will probably get hotter, but what we want to do instead is we want to pretend that somebody stopped by on the side of the road before the state troopers arrived and had a bottle of No-Mor Friction, and they're going to stick some No-Mor Friction in our hub that was starting to self-destruct. We're going to put just a couple drops of it in here. And we're going to watch how it'll cool off this situation and take the friction out. This hole is filled completely with ground up metal. See if you can get my finger in here again so we can watch and see the friction. See it bumping? Watch as it polarizes. The friction goes away. There's no more friction, there's no more heat. Let's see the meter one time. Can you see the meter now? I'm putting a lot of load on here, and it will not change. There's no frictional connection taking place in the hole. Let's watch our temperatures. We were at 202 or 205 or something like that a second ago. Now we're counting down. We're at 100. Now that bar of steel is radiating that heat off. This flashlight that we have, or this thermometer that we have, can you see the scale on it right now? Yeah. It will measure that light bulb from down here. That's how it works. So it's cooling off right now. Now, let's take a look at these pins and see how they've worn. This is going to show us what the No-Mor Friction product has done to eliminate the friction, the heat, and the wear. First thing that we want to do is take a look at some Q-tips. I have a Q-tip here. I'm cleaning out the hole that had motor oil in it. Can you see that? This is pretty much pure metal here. Can you see this? Now let's check the one that was used with the popular heavy-duty oil stabilizer product. Can you see that? Now let's check the one that was used with the same oil stabilizer product, except this time we had 1 drop of No-Mor Friction in there. Let's try to rub this one time so you can see what it looks like. There's no solid metal of any sort, only the color of metal on the Q-tip. Can you see that? Now let's take a look at the pins that we ran in the test for wear. And for folks who are watching this test, we are talking about eliminating friction, heat, and wear on your engines, your gears, your hubs, your ball joints, anywhere that you have friction heat or wear, inside your reefer unit compressor, all those places. If you have a pony motor, just 2 ounces is all it takes in there. Now, I'm going to put these Q-tips off to the side. We're going to wipe these pins off onto the towel and see what happens. This is the one that we did with the popular coil stabilizer product. Can you see this? That's the metal wear that we generated in the test. Can you see the end of the pin? That doesn't look the same as when we started. Can you see that? And you can see that, of course, there's nothing of the original pin on the end. There's no grinder marks. It's all smashed and worn. Now, can you see the one that we did with the motor oil by itself? Can you see it at all? Is it in the camera? Okay. Let's take a look at the one that we did with the motor oil. Sir, could you come over and just look at this for me? Because the camera can't see. And just let me know what you see on the end of this pin. I haven't wiped it. We haven't touched it. The end here where we did, look at that oil under the light. The oil on the end of the pin. You still see it? Do you see any ground up metal on the end of that pin? No. You wipe it off on here and see if you can still see the original grinder marks and all that on there. Right here on the end of the surface of the pin. Do you see the original? I made a grinder surface with the grinder back here. So you still notice that?
Yes.
What he was noticing is that we haven't got any change or any wear at all that happened. And that's because if you can't get your parts to rub together, you won't get them to wear out. The No-Mor Friction product creates a 1-molecule force field around all your components that keeps them from generating heat, keeps them from wearing out. Let's take a look at this over here. This is just a testimonial from one of the customers who used the product. He goes out to California quite often, and he comes back up a big hill called Donner on his way out of there. He said after the No-Mor Friction, climbing the hills, his engine oil went from 175 down to 150. His transmission temperature went from 275 down to 210 in hard pulls. The temperature of his rear ends went from 175 down to 150. He's gained 5 to 8 miles per hour every time he climbs that hill with similar sized loads. And his truck has been getting 0.8 of a mile better per gallon ever since. Now,
So how much you put in with oil?
that's exactly what we're getting at now. Here's how the product works for you and your equipment. Can you see the back of the bottle? Isn't all that. The component in the product that blends antifreeze and water together will come out when you change your oil. The polarization that gets rid of the friction, the heat, and the wear will last as much as a year's worth of oil changes before it dissipates. You're going to put 12 ounces into each one of the rear differentials, 16 ounces, which is one of these small bottles here, into the transmission. A gallon will do the engine, the transmission, the differentials, and the steer wheels one time, and it will do your engine again next year. If you would like to order some of the product, or if you have questions, just call the number on the top of the TV screen right now. Now we're going to talk about the No-Mor Friction diesel fuel enhancer product a little bit. Can we see this here? The No-Mor Friction. I'm going to grab a drink of water here for a second.
I got it, bro.
Okay.
I play second beat ready.
I have a slug of water here. Do you have it in here now? The No-Mor Friction diesel fuel product is also ionic, and it works a different way from most of the products that you've ever seen. Most diesel fuel products that you ever see on the shelves will use heavy-duty degreasers to get rid of the gelling components in your fuel. Cutting the wax out of your fuel will stop gelling, but it also cuts a large percentage of the BTU energy value of your fuel away, and it gets rid of your lubrication that you're supposed to have in your fuel, especially since the low sulfur fuel. In order to get rid of water, most products will use absorbents to absorb the water. This collects all the water together into one puddle and sends it out into your water and fuel separator, and if that happens to be full, it'll send all that water through your injector all at one time. To make things run better, most products try to put some extra flammable ingredients in there. Here's how the No-Mor Friction product works. This is the highest grade product that there is for diesel. The formula hasn't been changed since 1954, and it works a different way. Instead of trying to dissolve the wax, instead of trying to absorb the water, instead of trying to add flammable ingredients to your fuel, it works by reducing the interfacial surface tension between all of your fuel's molecules and causing everything to go down to the smallest molecular unit. All the water that's in your fuel disperses to individual molecules. All the wax that's in your fuel disperses to individual molecules. And your fuel itself disperses to individual molecules when it comes out of your injectors. So instead of having a liquid mist in your cylinders, the No-Mor Friction becomes a complete vapor that is ready to combust completely, providing the most horsepower possible for your engine. Now, instead of dumping a whole gallon of this into your fuel or a whole bottle of it, No-Mor Friction uses just 1 ounce to 10 gallons. So a gallon of this will create 1,280 gallons of super diesel fuel. We're talking about increasing horsepower and reducing emissions by up to 50 to 90%. If you have any questions, please call the number on top of the TV, or to order some No-Mor Friction. We do ship nationwide. Folks are standing by to answer your calls. Call the number on top of the TV here, toll free.